Welcome to this video lecture. In this video lecture, we are going to discuss about block diagram reduction method to calculate the transfer function in control system. So, this is block diagram reduction method. Reduction method to calculate transfer function in control system. So, let me first discuss what exactly is block diagram. So, block diagram is you can say a graphical method to represent any control system. So, we can represent any control system with just a block, like there is a system in this, and we are giving some input to the system, and we are getting some output yt from the system. So, any system or control system can be represented by just a block. For example, if we talk about an RC network in which we have a resistance and a capacitance connected in series, and we are giving some AC input to this network, and we are getting some output from the output terminals of this RC network. We can represent this RC network with just a block here. We can represent this RC network with just a block, and by representing it by just a block here, we are applying, this is RC network. We are giving some input V in, and we are getting some output. So, block diagram is basically a graphical method to represent a control system. So, basically there are some terminology or some elements of this block diagram method. So, we generally use a summing element. So, let me first write it, summing element. So, summing element is basically a point where multiple signals can be added or subtracted. So, suppose this is the summing element, and we are giving two inputs x1 and x2, and suppose that both the signals are added, then the final output of this summing element will be x1 plus x2. So, two or more signals can be added or subtracted in the summing element, and just one more example. So, suppose there is signal x1 which is added, signal x2 which is subtracted, x3 is also subtracted, x4 added. So, the final output of this summing element will be x1 minus x2 minus x3 plus x4 and so on. So, the first element of block diagram is a summing element, and the second is a takeoff point. So, takeoff point is basically a point. At this point, basically output can be again feedback to the input, and basically it is used for the feedback purpose. So, suppose we have a block with the gain G1, and we are applying some input x1 to this block, so that we are getting output x1 times G1, since these all quantities are in the Laplace domain, and we know that the output of any system is the gain multiplied by the input. So, the output of this system will be the gain G1 multiplied by the input x1, and suppose this is the point, takeoff point, where we are taking the output and feedback to input of any network or the same network, then this point is known as the takeoff point. Now, the value of this takeoff point will be same as this x1 and G1, since it is connected to this directly. So, this is also x1 times G1. So, these are basically mainly two elements which we use in a control system. So, now let us discuss the reduction methods, or more precisely the reduction rules for block diagram reduction method. Let me write it here. So, the first rule is, if the blocks are connected in series. So, if the blocks are connected in series, so suppose we have two blocks G1 with again G1 and gain G2 are connected in series. There may be multiple blocks. I'm taking 2 blocks here only, but there may be multiple blocks connected in series. So suppose some input X is given to these 2 blocks G1 and with the gain G1 and G2. So what will be the overall output in this case? Since at this point the output will be input, this is X multiplied by the gain. So at this point we will get X times G1, and the final output will be this signal multiplied by G2. So the final output in this case will be X G1 times G2. So this block diagram, if connected in series, multiple blocks are connected in series, equivalent diagram of this can be represented as since in this case both the gains are multiplied, we can represent it as G1 G2 with a single block, the same input X and with the same output X times G1 G2. So if multiple blocks are connected in series, then we can represent them with a single block with all the gains multiplied. So this is the rule for blocks connected in series. Now in the second case, what if the blocks are connected in parallel? So if the blocks are connected in parallel, so let us take such case in which we have 2 blocks with the gain G1 and gain G2 connected in parallel, and after the output these 2 are added, and then we are getting final output, and the same input X is applied to both the blocks. These are 2 connected in series. Now at the output of this block we will get output X G1, and at this block we will get output X G2, and since both the signals are added by the summer, the final output will be X G1 plus G2. Now how can we represent these blocks connected in parallel with a single block? So the equivalent diagram of this case can be, since the input is X and the output should be X times G1 plus G2, what we will do, we will add all the gains in parallel. So the equivalent diagram, the multiple blocks are connected in parallel, will be either if the blocks are added, if the signals are added, we will add the gain. If the signals are subtracted, we will subtract the gain. In the same case, if the signals are subtracted, we will subtract the gain here. So this can be either added or subtracted. So this is the equivalent diagram in case the blocks are connected in parallel. Now the third rule for the block diagram reduction is shifting of summing point after the block. So shifting of summing element or summing point after the block. So in this case we have a summing element before the block. Suppose this is a summing element, and there are 2 signals X1 and X2, and both the signals are added. Let us assume this that both the signals are added, and we have a block here with the gain G1. The final output in this case will be, since this both the signals are added, the input to this block will be X1 plus X2, and this will be multiplied by G1 in order to get the output. So the final output in this case will be G1 times X1 plus X2. Now if you want to shift this summing element after this block here, then what will be the equivalent diagram? So in this case, since we have signal X1 here, and this will be G1, and we have shifted this summing element in this position after the block, and we have added this signal. Now the output should remain the same. So the output in this case is G1 times X1 plus G1 times X2. So this output should remain the same, but here at this point we will have output X1 times G1. Now if we simply add or simply give signal X2 to this summing element, then in that case the output would be X1 times G1 plus X2, which is not same as the actual output. So this is not the output in this case. So what we will do, since it is X2 is multiplied by G1 gain also, so first we will multiply the X2 signal with the gain G1, and then we will apply it to the summing element. So X2 first multiply by the gain element G1, and then it will be added to the summing element, and in that case we will get the correct output, which was the output in the previous case also. So what is the rule? If you want to shift the summing element after the block, we will multiply the signal x2 with the gain in between. So, this is the rule of shifting summing point after the block. Now, just opposite case of this, if we want to shifting of summing point before the block. So, in this case, let us take example. We have signal x1 and the block with the gain g1, and we have summing element after this block, and we have signal x2 added to this these two signals, and then we are getting final output. So, in this case the final output will be, since at this point we will have output x1 g1, so both the signals will be added. So, final output in this case will be x1 g1 plus x2. Now, if you want to shift this summing element before the block, in this case the equivalent diagram will be, so if we shift this, so this summing element is shifted before the block, and this is the block with the gain g1, this is the signal x1 which is added, and the final output in this case also should remain the same, which is x1 times g1 plus x2. Now, if I simply apply signal x2 to this summing element, in that case the output of the summing element will be x1 plus x2, and the final output in that case would be g1 x1 plus g2 x2, which is not the same as the previous output. So, this will be wrong. So, what we will do, we will first divide the signal x2 with this gain g1. So, I will apply this block with the gain 1 upon g1, and this signal x2 will be applied to the signal, and what we will get in this case, we will get x1 plus x2 by g1. Now, this signal will be multiplied by this g1, and we will get the correct output as like in the previous case. So, the rule is, if you want to shift the summing element before the block, then the signal is divided by the block in between. So, let me summarize these two cases once again. If you want to shift the summing element after the block, then the signal is multiplied by the gain in between, and if you want to shift the summing element before the block, then the signal is x2 is divided by the gain in between.